Alright, welcome to section 3 of the chapter 8 videos for Algebra 1 at Graph School. This one is going to talk about shifting and reflecting, or sorry, not shifting, just reflecting points in graphs. We'll go through it pretty quickly and then I'll do some examples. It should be a pretty straightforward section though. So, a graph can be flipped across an axis. When you do that, it's called reflecting the graph. So if you reflect across the y-axis, you're going to be flipping side to side. If you reflect across the x-axis, you're going to be flipping top to bottom. And then if you do both of those, both side to side and top to bottom, in effect you flipped across the origin. Okay, so we'll talk about how to do that. What I like to do is draw a little axis and visualize what I'm doing. So to reflect across the y-axis, what do? So draw a little graph, and imagine you're a point sitting right here. This is the y-axis, of course. If you reflect across that, you're going to go on the other side, kind of like a mirror image of where you were to where you're going. So whatever your coordinates were here, x, y, if you come to the other side, whatever your x coordinate was, it's now going to be the same number but negative. So your coordinates are negative x, comma y. So when you reflect across the y-axis, your y value doesn't change, but your x value changes to the negative whatever it was. So to do that, if it's an individual point, just change the sign from positive to negative, or if it was negative, change it to positive. And if you want to reflect an entire graph, so how do you change the equation? You do the same thing, except instead of changing the numerical value of the x coordinate, you're changing the entire variable x into negative x. So if you started with y equals mx plus b, your new equation would be y equals m, and then you put in a negative x plus b. So in effect, it changed the slope from positive to negative without changing anything else. Okay? What if you want to reflect across the x-axis? So imagine the same little graph right here, but now we're reflecting across the x-axis, which is this axis. So this point is going to come down here. Its x value stays the same, but its y value becomes negative. Okay, so you replace the y value, and since we're using function notation, it might be actually f of x. Into negative y or negative f of x. Notice the negative sign is in the front, not inside, because f of x, remember, is all one piece, the output value. So here you might have the new equation be negative y equals mx plus b. And then, of course, if you want to solve for y, you have to divide or multiply both sides by negative 1 to cancel that out. And then you'll have a negative slope and a negative intercept. So that will reflect from the top down. To reflect across the origin, you're making both changes. So you're changing x and y into negative x and negative y. So it's just, think of it as first reflecting across the y-axis and then reflecting across the x-axis. So the combination of both of those, like if you started here, first you go over here, and then you go down here. That's the same as if you went right through the origin. So reflected across the origin means straight through, equidistant on both sides. So whatever distance it is from here to here, it'll be the same distance from here over to wherever that point is. My picture is not perfect, but hopefully it illustrates the idea. Okay? Now, an important thing to consider is that some graphs are symmetrical. So when you reflect it, it doesn't actually change anything. Let me show a quick picture of one that's symmetrical. So a parabola is a good example of a graph that's, well, I've drawn it relatively okay. If I was to reflect it over this axis right here, wow, I can't draw it at all, sorry. If I was to reflect it over this axis, this part here would reflect over on top of this, and this part here would reflect over on top of this, and the net result is I would have the exact same graph and the exact same equation that I had before. So mathematically, that's how we define something as symmetrical. When you flip a graph or reflect a graph, you end up with the exact same graph and equation. Same graph, and I'll even write it here, and same equation. Obviously, the graph is a representation of the equation, so if one of them is the same, the other has to be the same. But I'll write it down just to be clear. So a good example of graphs that have symmetry are parabolas. Linear equations typically do not have symmetry because when you reflect them, they're going to change slope or change intercept. Something will change. But with a parabola, you can see it in the equation. You have y equals x squared. If you change x to negative x, because you're squaring it, it doesn't matter whether it's positive or negative. It's always going to come out the same. So reflecting over the y-axis doesn't have any effect. Okay, let's do a couple of examples. let's reflect y equals 2x minus 5, and let's reflect that over the x-axis. Okay, to reflect over the x-axis, you want to change y into negative y. So we label this guy as our old equation, and then we're trying to find the new equation. We're going to take the same equation and we're going to replace the y variable with a negative y. So then we'll have negative y equals 2x minus 5. We'll divide both sides by negative 1, or if you like to think about it, multiply both sides by negative 1. And then we get y equals negative 2x plus 5. Remember, both things in the numerator are being divided by negative 1, so both of them change sign. And so this is our new equation. Alright, so we want to graph the old one and the new one. The first one is a 2x minus 5, so its intercept is here at negative 5, and the slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and down to back 1. So I'll try really hard to draw a straight line. It's not easy with the mouse, trust me. Alright, so there's our old line, and we label him old. We've got the intercept labeled, that's important. And we should probably label these increments as 1, 2, 3. Label that one as a 4 so it's clear. Let's graph the new one, negative 2x plus 5. So that one's starting up here at 2, 3, 4 at positive 5. But its slope is negative 2, so we're going down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. I'll try to draw, and there's a point. I'll try to draw this line in pretty good. Okay. So by the time you've finished it and you label this one as your new one, there's a couple things that you should notice. The first thing you should notice is that they cross on the axis. Anytime you reflect a graph over an axis, it'll cross on the axis because the point on the axis, it has nowhere to reflect to because it's already on the axis. The second thing you'll notice is it looks symmetrical after you've finished graphing both of them. So if you were to draw a horizontal line along the axis of rotation, or of reflection, which is this x-axis, if you draw this horizontal line, it looks like a mirror image top and bottom. That's confirmation that you've done it correctly. Once reflected, it should look the same on both sides. If it doesn't look the same on both sides, you should go back and check your equation or your graph, because most likely you've done something wrong. Alright, let's do one more example, and then we'll be finished with reflections. Let's do a parabola. Y equals, no, we can't do that. Let's just do, sorry, we can't do dilations yet. Let's do x squared plus 2 over the x-axis. Okay, that's fine. So to go over the x-axis, we're going to change, again, the same thing, y into negative y. So here's our old equation. Here's our new equation. Negative y equals x squared plus 2. If I multiply the whole thing by negative 1, I'm going to get y equals negative x squared minus 2. Okay, so this will give us some practice graphing parabolas. The old one here, x squared plus 2, I start at plus 2. So I've shifted my graph up 2. So it's kind of like what we learned about in the other section. You could think of it as a y-intercept is positive 2, or taking the base parabola y equals x squared and shifting it up 2. Okay, so from here we're doing a parabola because it's x squared. So we go over 1, up 1, over 2, up 4, back 1, up 1, back 2, up 4, and we draw in our parabola. Okay, so there's our base parabola. We'll label that guy as old. Okay, then we have this one as our new parabola. So it's been reflected over the axis. So imagine you have a horizontal line here, or like a paper, and you fold this graph in half. It's going to end up down here somewhere. Okay, so you take this one here, and you plug it in. Negative 2 is our starting value, negative 2, and you can see it's been kind of reflected down there. Now from here, normally you would go over and up, but because it's been reflected, it's upside down. This negative sign in front of the x squared is confirmation of that. And so you're going to go over 1, down 1, over 2, down 4, over 1, down 1, over 2, down 4. Again, we're going down because it was reflected, and there's a negative sign here in the front. Okay, so you can see that this parabola up here is a mirror image reflection across this axis, and it comes down here, and we should label this guy as new. And lastly, we should make sure we label this as 2. Maybe label this as 2. Maybe label this as -2, so that we can tell what increments we're counting by. Okay, so when you're reflecting, again, it should be symmetrical over the axis after you finished graphing it. And they should always cross, if they do cross. This one doesn't cross, but if they do cross, they'll cross on the axis. All right, that's it.